Here we are looking at some more examples of how to use the CSI technique, we'll call it the CSI technique, to figure out how to write algebraic expressions. We call it the CSI technique again because you are going to do the math, you're going to trick your brain into telling you how to do a question, and then you're going to switch it back out into algebra after you figured out by working backwards what it is that you actually did. So this technique involves starting out by replacing the variables in your question with made-up numbers that you choose. Often 10 is a good number. It's a nice, easy number to work with. Sometimes you want to try something else. And then you do the math and you write out your steps to make sure you can track what you're doing. Then you look and you see what you did, and after tricking your brain into answering the question for you, you switch the number that you made up in step one, you switch it out and you throw the variable back into the question, and then you should have your expression. So let's look at this in action again. This question tells us the story of John, who buys 3 books at X dollars each and pays with 5 bills of Y dollars. How much money does he get back in change? Now, without the CSI technique, I've seen a lot of students look at a question like this and think, well, the answer's probably got to be like 3 books at X dollars each. Maybe that's 3X. And then 5 bills of Y dollars. Maybe that's 5Y. So I guess 3X minus 5Y. And then if they're good, they remember to put units on and say, okay, let's 3X minus 5Y dollars. This is an incorrect answer. Okay, so don't do this. This is bad. Don't do what I just did here, right? Let's park him off somewhere here and see this is not going to be end up being a right answer. And maybe with the CSI technique, our common sense has the upper hand. It helps us keep track of what's going on. So if you look at this here, let me replace X with a number. I want to avoid using number that's already showing up in the problem somewhere. So let's pretend the books cost, I don't know, $10 each. And let's say that he's got 5 bills of Y dollars. Let's make the bills $20 bills. Okay, so 3 books at $10 each. That's going to be 3 times 10. So I'm writing out my steps. I'm showing them I'm doing 3 times 10 is 30. And then 5 bills of Y dollars, that's 5 times 20 is going to give me how much money he's paying with. And then this, okay, so this is 30. This is 100. So if he's buying $30 worth of books for $100, how much money is he going to get? $70 is how much money he gets back. Now, where did that 70 come from? Okay, I did 100 minus 30 to get 70. And where did that 100 come from? That was 5 times 20. And this 30 was 3 times 10. So that's how I got my $70. Okay, now that I've really tracked my steps, like once I add these numbers here, the 70, I could probably do that in my head pretty quickly, but by writing it out and seeing where the 70 came from, I've set it up that I've tricked my brain into telling me how to solve this problem with variables. Because remember, 20 is just a number I made up. 20 wasn't 20. Let me go back and look at my problem. 20 was y, right? So 5 times y, and the brackets, you don't really need them here, but I'm writing them so you can see. And the 10 back in the problem was x. So it was actually 5y minus 3x. And let me include actual units in here, 5y minus 3x dollars. Now see here, when I was kind of just going by my skills in algebra, which I'm still working on developing, I might have ended up switching these up. But when I throw in actual numbers, my common sense helps me figure out what the problem should be, and I get the correct answer, which is that he gets back this amount of money in change, 5y minus 3x dollars. Okay, let's see another example. More examples always better. Marie is X years old and her brother is Y years old. No, she's not. Marie is, let's say, I don't know, 10 years old. And her brother is 20 years old. Again, we could make up any numbers we want. Their grandmother is 3 times the sum of their ages. What expression represents the grandmother's age? So grandma is 3 times the sum of their ages. The sum of their ages. That's adding together, right? So that means I could probably do this in my head right now. She's 90, right? Where am I getting 90 from? I'm saying the sum of their ages. That's going to be a plus between their ages. And her age is 10. And her brother's age is 20. And then once I got that 10 plus 20, 3 times that, I did 3 times the 10 plus 20, right? Because that's what got me to 90. 10 plus 20 is 30. 30 times 3 is 90. That's how I did it. And the 10, again, is not really a 10. It's an x, right? I just pretended it was 10 to help me do the math. The y is not, sorry, the 20 is not a 20. It's a y. So my actual answer is going to be 3 times x plus y. Remember, this 90 doesn't matter at all. That's just the result I got when I was using numbers. This is what I'm really looking for in this problem. 3x plus 3y years. Years is a unit of time, so let's not forget that that's a unit. That expression represents grandma's age. 3x plus 3y years. Make sure on your birthday card to grandma say, happy 3x plus 3yth birthday, grandma. All right, question 6. Let's try another one. Write the expression representing the sum of two consecutive multiples of 3. My goodness, all these words here. Got to make sure I understand what they mean. So consecutive, in case you don't know what that means, consecutive just means one right after the other. So for example, 3 consecutive numbers could be 1, 2, 3, or it could be 7, 8, 9, right? Or it could be -8, -7, -6. Consecutive just means one after the other. And multiples just means numbers that are multiples of this other number, right? So if you can think of some multiples of 3, like here's a whole bunch of multiples of 3. Probably the first one you think of is 6, and then there's 9, there's 12, there's 15. It's easy to forget that 3 is actually a multiple of 3. And mathematically, 0 is a multiple of 3 because some number times 3 gives us 0, right? 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6, and so on. But as long as I'm sure most of you instinctively would start with 6. Even if you start with 6 and you forget about these guys up here, that's not going to make a huge problem for this one here. At least even if you just go with these first two numbers that jump into your head, 6 and 9, you can already say to yourself, that's enough to do a little bit of math on. So the sum of two consecutive multiples of 3, the sum means adding. So if I'm choosing 6 and 9, then I'm going to say, okay, well then the sum of those two is 6 plus 9. That's 15 for me here. Okay, now let's turn this into algebra. Now, there's a more elaborate way of representing a multiple of 3. You could say any multiple of 3 is 3n, and then the next multiple of 3 after that would be 3 times n plus 1. I'm going to do a slightly simplified version, which isn't as mathematically sound, but technically, unless you have a concept of number sets, like writing it this way doesn't actually make it more sound than what we're going to do now. So I want you to look at these two numbers, 6 and 9, and no matter which multiples of 3 you would pick, it would still work the same way. If 6 is your first multiple of 3, and consecutive means the next one along, that's why we went to 9, what do you have to do to 6 to turn it into 9? Well, you're doing plus 3, right? And that'd be the same if you picked 12 and 15 as your multiple of 3. Again, you'd just be adding 3 to get to the next one. Anytime you have one multiple of 3 to get to the next one, you just have to do plus 3 to get it. So that's what's happening here between 6 and 9. 6, if we think of 6 as x, then 9 is just x plus 3. So here in our expression, we have x plus 3. And the sum of these two things, I could simplify this, right? X plus, let me get rid of the brackets, thinking of distributing a positive 1 there. This becomes 2x plus 3. This is the sum of two consecutive multiples of 3. Now you saw here that when we were talking about multiples of 3, we did plus 3. If this question were talking about something like 3 consecutive multiples of 5, then your 3 consecutive multiples could be x plus 5, x plus 10, right? And you see this again with numbers. We think of multiples of 5 like 10, 15, 20. they're all jumps by 5. Whenever you're dealing with multiples, then the jump is the same as the number that you're getting multiples of. We'll come back to that because this whole area, there's a whole body of word problems that rely on this kind of question. So stow that away in the future. But the expression representing the sum of two consecutive multiples of 3, which is the question we were asked, is this one here. All right. Now an even more challenging question we have here. If you are 2b years old now, how old were you b plus 3 years ago? This one also has two ways of tackling it. I'm going to show you the way that I think is best suited for figuring out how to do a question like this. Because you might be looking at this and you say, okay, well, the CSI technique says to replace the letter with a number, right? I'm actually going to suggest that you replace this whole algebraic expression, 2b, with a number. If you are 2b years old now, let's think of this as, okay, I'm 13 years old now. How old were you b plus 3 years ago? Instead of focusing really in on the fact that there's a b here, a b there, I'm just going to make up a number here and say, okay, how old was I 5 years ago? Again, I'm picking numbers that don't show up already in the problem. So if I was 13 years old now, which a lot of you are that are watching this, how old were you 5 years ago? Well, without writing it out, you would instinctively get an answer of I was 8 years old. So say to yourself, how did I get 8? Well, I did 13, and I guess I did minus 5, right? That minus there, if you're thinking in terms of algebraic expressions, if you're not using numbers, might be tricky to come up with. But when I just have numbers, my brain knows, yeah, the way I get to 8 from 13, the way I knew that the answer would be 8 was I subtracted. Now that you've tricked your brain into unlocking this problem for you, go back in, replace 13, which isn't 13, with 2b. Replace 5, which isn't 5, with b plus 3. And then I'm going to subtract them. Now you guys all know that if I'm going to be subtracting something that's got two terms here like this, it's super important that that minus applies to the whole thing. I'm going to be distributing that negative, turning both of those negative like that. So I make sure to put this in brackets here. And now if I want to simplify, 2b minus b minus 3 becomes b minus 3 was my age in years, b plus 3 years ago.